On the channel this week, we start building a 12S large-scale dropship. And it goes like this, and then it goes like that. Powered by T-Motor. Racing! Yeah! Yes! Welcome to the show, the Racing Show! And we appreciate you very much for tuning into this exciting episode. I am Harry.
And I'm Richard. And this is a very special one because it's all about VTOLs.
Yeah, VTOLs, what's another name for this particular design? A quad plane.
Quad tilt rotor, vertical and takeoff and landing.
Yes, it's all about those hybrid designs out there. And this one specifically, we're going to be making a dropship configuration.
Yeah, cool.
Inspired from those cool as sci-fi films out there. But also very specifically, we're going to try and attempt what Boeing and Bell could not attempt.
That's right. So what is commonly known now as the V-22 Osprey. But what they really wanted to do is they wanted to make a quad tilt rotor known as the V-44. So that's what we're going to be sort of mainly inspired by this particular build.
Yeah,
it's going to be quite large. We've got some big motors and propellers, all thanks to T-Motor and some ESCs to go along with it.
Yeah. So what are they? 28-inch propeller, so they're fairly large and it's going to be fairly big scale. So let's jump into it. We're going to go and look at the design that we'll come up with on software.
That's right.
And then we're going to start the build. So it should be exciting. Start the build, and make sure if you haven't done it already, make sure you subscribe to the whole series and check out all the other builds that we have on the channel. It should be exciting.
That's right, because this will be quite an ordeal on this one. Very exciting, and obviously flights are to come.
Yep, autopilot, all sorts, exciting stuff. In 3, 2, 1, race!
And we're back.
Yes, and it is exciting because the parts just arrived.
That's right. So the mailman has been busy and he's brought us some new packages because T-Motor have come on board and they're helping us up and teaming up for this exciting build.
Yes, it's very cool, and we're going to be making a tilt rotor and a quad tilt rotor specifically.
That's right, so a quad plane as it were. So what is a quad tilt rotor?
Yes, okay, so a drone normally sits with, the general configuration is 4 motors in a fixed position.
Yeah.
But with a quad tilt, just like the name is, that it will tilt when in forward flight.
That's right, so vertical takeoff as they do, and then the rotor blades will tilt forward and then you'll extend into forward flight. So it's very exciting. There's lots and lots of different iterations. Some have got wings, some have got some of them are tail sitters. There's lots of versions. So what is the one that we're going to endeavor to undertake?
Yes, the one that we're going to be looking at is very similar to the V-44 from Boeing and Bell.
That's right.
And the one that they didn't actually end up making, they made the V-22
Osprey. That's right.
Yes,
so it's used in service today, and it's on something like a film like, say, Michael Bay might use on Transformers. Very cool aircraft.
Yeah, very cool. And this is a quad type design, and very unique.
That's right, and say something like other films would include something like Edge of Tomorrow with Tom Cruise.
Like a dropship type style. And that's the kind of style that we'll be going for in this iteration. So, stick with us on this exciting journey, and we're going to be jumping over and have a look at the parts that just arrived. Okay, so there you go, right there. This is the U11 Mk2. 120 kV is the motor that we've chosen for this particular build, and a very powerful motor at that. And there'll be 4 on this new design, which is pretty cool. The U8, which was the cousin of this particular design, was used on our previous design, which was the
world's largest 3D printed heavy lift drone.
Yes,
Okay, the 3D printer drone.
Yeah, the 3D printer drone, and that one was designed for efficiency and long flight times, where this is just all about power, and that's exactly what we want for this design. So it's pretty cool.
Yeah, it's very cool.
And can't wait to actually see this with the propellers on. So let's go and check out what the ESCs are.
So ESC time. So we've got some flames. So these are the V2, and they are pretty awesome to say the least. They're 80 amp ESCs, and with a peak rate of 120 amps. And there they are. They're sitting there. Oh, there's got the zip ties. Maybe we should cut them off. But anyway, so there they are. This is the V2 version. It's got 6 to 12S, and I think we're going to be running this bad boy in 12S, so we don't have to worry about the 6. And it looks pretty good. So
Now we can have a look at them.
that's right.
Another one you missed?
Yeah.
Oh, cool.
Okay.
They're outside the box. That's cool.
Alright, so let's... Okay, so we can move those boxes aside. But this is what we're looking at. So there you go. So that gives you an idea of scale. There you go. Yep.
Good heat dissipation.
Good heat. Yep.
And what are the cables? We've got cables going
So
to
we've
the
got
motors.
3 phases at that end, which is good. So those were the ones that will go to the motor. That's just sitting here. So 3 cables. And then you have what is
All the
the
other
power ones, the power necessary one, and this will be the PWM input, and you'll also have another one for telemetry and another one for
firmware updates. So it's
That's
all on there, and that's great to see. What would you say about the V2 version?
it looks good. It's slightly wider, would you say, Harry?
Elongated, I'd say.
Elongated.
What about weight? What do you think?
About the same.
Yeah, all
About
good.
the same, yeah.
Okay,
So it's good, but yeah, it's going well. So that's 2 items down, and then we need to get the next one, which is the blades, the propellers. Basically, the part that lifts it actually in there. So you got the motor, you got the ESC. Now we need a propeller. Let's go into it.
Okay, so let's check out the propellers, and they're quite unique. They're very iconic tri-blade configuration, and very cool to see at this size. After all, and not every day do you go out and see something like this.
That's right. So they are what, a G28 with a 9.2 inch pitch.
Yes, let's have a look. Yes, a G28 with a 9.2. Okay, so the cool thing about a tri-blade prop is that you can effectively use a propeller of this size, but now it's actually this size with the same thrust, because it's now a 3-blade configuration.
That's right, in terms of power and thrust, right?
Yes.
So you can reduce the footplate.
Yes, very cool. A footprint of the propeller. Yes, and they also look very cool. So let's go and have a look. And it comes with a manual and all that sort of stuff.
So it comes with 2 propeller sets, right? And you got 2 center locking nuts?
Yes, and they are quick release designs. That's pretty cool. There's ones, but we'll be jumping into that more later on. But yes, there you go. So they come in their own little sock, and that's pretty cool. Center sock. And there you go. So there you go. That's 1 of 3. That's pretty cool.
So 1 of 3 to make up a tri-blade. So
Yes.
you reckon you get 2 more?
Yeah, sure. There we go. And maybe pop that down there. So you can put that kind of in the 3-star kind of configuration. So you can kind of imagine it, what it will look like that. And as an example, this is a normal 5-inch prop. So you can imagine what that tri-blade. So there you go. So that's just a little bit of scaling for you. So it's pretty cool. And let's go and carry on.
Okay, so we've got to put the propeller together. It's quite a unique, iconic propeller. So it's a tri-blade prop. You've got to install it together, and it's got a self-locking device, I guess you call it. So you've got the different collets and things like that. So when it comes in, it kind of looks a bit like this, and that piece is installed there inside. So it looks a bit like this one here, over here. So this is the right-hand one. And you can tell the difference between, this one's the right one because it's just black, whereas this one's a left-hand one because it is white. So we've got that. And so we want the left-hand one because all these are labeled with little L's on the end.
Oh yeah, there's an L, yep.
L and a C, so each one's got, so this is a C blade. This one here has got an A. This one's got a B. So this is one set.
Yep.
So that's what we want for this first set. So we don't need the motor just yet. Depending on which particular motor you're using, U11 2, there's also a U8, but when you're using the U8, you use this particular collet. It's just the nature of the beast for that one. We won't be needing that because we're doing the U11. So you take the center collet, which is the left-hand one. So they have A, this is the C one obviously, so C goes with C, B with B, and A with A, like that. So what you do is you also put, as you do them, you put a second one in, and then you put these little grommets on.
Okay, so first of all we need these little fellas, and how long are they?
The 15s. They're 15 by 3s, yeah.
Yeah. And we pop those into the centre pieces.
Yep, down she goes. There you go. Alright, so that's the first stage, that's where we're at.
Okay, and now we put the next layer on.
Your eyes confess what lips won't say.
Okay, so yeah, collet is on there.
Which way up? This again.
Where you want to do it, so it's got the, what do you call it, offset to allow it to go flush. Otherwise, if it goes around this way,
so it can only go on one.
it was just sitting in the air, you see. So it has to go in that way, so it's flush.
That's what you want.
Cool.
Okay, so the next one you just use the same kind of bolts.
Exact same, 3 by 15s. So now we've got our motor.
And this is the U11, so that's going on there. And what do we get? We get that bottom section.
Mm-hmm. Line it up with the little holes. Line it up with the bottom holes.
You can see the holes through there.
Yeah, and then these particular ones go in there. So we've got 4 of them to go on, I think.
4 big ones for this particular motor. It's quite cool how it's got integrated quick release. Just make sure you get it the right way around. Don't put the wrong one on the wrong motor. That would be bad. But it'd be quite good in transport. I guess the idea is that, you know, so it's a big copter that you're designing, which is, this one is fairly large.
Yeah, it's fairly large, yeah.
Then the good thing about that is that you can take the propellers off when you're transporting them, pop them back on. Okay, so then once it's all lined up, you just spin it on.
Okay, so it's all mounted, and yeah, it's good to go. And there you go. Obviously, the motor needs to be attached to something.
Yeah, we're going to mount it. That's the next thing, but it looks cool, doesn't it? Very cool.
There you go.
That's the prop. That's one of them. One of 4. So there you go. So that's all looking good, and we've been doing some serious CAD work in the background. Yeah, making it look good for this design. Okay, here it is from the front, and it's its nose, and there you go. This kind of gives you an idea of what it might look like. And how big is this guy? So there's the back. Sort of in the sort of around 2 meters, maybe like 1 meter or so wide. And it's just mainly just to clear because of the size of the propellers. So it's going to be a substantial looking guy. And it should look pretty cool. So there you go. That's kind of an idea of what it looked like, very much based on the various films that we talked about, like Edge of Tomorrow and Elysium and all those good science fiction films. So we want to make a science fiction dropship. So you got to look the part, right? You got to look the part. It might change to the final iteration, but that's a good starting point. So there you go, and let's go over and print her out. Yeah.
When the truth stays cold, you pull me close.
Okay, so it's coming along. We've got about sort of roughly 2 hours to go for that part, which is the motor housing. So it's making, here's the model that we're working on. The propellers are getting worked on over there.
For the model? For
this little model here. Just to give you an idea of scale. And he's about 17 minutes, there you go. They'll be going on top of here just for looks, just so you can sort of see an idea of scale. So this guy's already been printed out. We did in 2 prints, didn't we? This print here was one, and then the individual tilts.
For the nacelle.
Propeller tilts, which is what the propellers are going to stick onto, just so we can get an idea of what is happening. So there we go. So forward flight, as it were, forward flight, and then when it's landing, it goes like that. Like that, and comes down. So that gives you quite an accurate representation. And these are a larger version of what these are, the motor cowlings. So a little bit more to go to make up the model and a motor housing, and then that way we can sort of see what it looks like in the small scale and also in the big scale. Cool. Remember what scale it was in?
10%.
10%. All right, so 10% of that.
Yeah, there you go. So that's the true size.
Yeah. So yeah, it's a bit bigger to go, and that's what that sort of. So you can sort of see it there.
Yeah, you can see it coming
through. It's coming through. Okay, so this is where we are. We've got another 3 minutes left on the build. So there she goes. Look at that. I think that's the biggest one. We're maxed out the build plate, haven't we? There. That's what you call in a cell. Nice. Look at that. Okay, so there you have it. This is the kind of sort of idea that we're talking about. What will happen is in vertical takeoff mode, we'll go up into the air like a drone, and then all 4 motors will tilt forward, and then you'll be in aircraft mode. So there you go. That's the sort of general idea of kind of what it will be like. It's pretty cool though, isn't it? Like that. And then obviously this is a scale one, and then this is the full size.
What size KV motor was that?
It's 120 kV, hang on. Yep, 120 kV U11 the Mark II. There we go. Little insignia up the top there.
And 28-inch props.
That's right, so we printed these out just to give you an idea of size. And this is effectively what it will be like. We have 4 of these, and it will effectively rotate like this. So obviously where the bar is, that will be the internal strut, and there'll be a wing there, wing surface area. But effectively it goes like this. It rotates up to full vertical takeoff, and then obviously the aircraft goes up with it, and then rotate forward, and then you get that nice forward flight. So without further ado, we're going to send it off, and we'll see each other on the next one. Head back to H&R Drone Racing HQ.
You want control but won't commit. You wear a mask that doesn't fit. You never lie but nothing's true.
Okay, we're back. Yes, that was pretty cool, and we're going to be carrying on with this series. It should be fun. It should be something new, something exciting too.
That's right, it'll be an interesting one. Lots of engineering aspects that have to come into play correctly for this to work.
Oh yes, yes, it should be exciting, and it's something new for us as well. Autopilot, that side of autopilot, which is known as Q-plane. But we're going to be diving into that.
Yeah.
Make sure, if you haven't done it already, make sure you subscribe to see all that coming up. It should be exciting. Very cool.
Yeah, that's right. It's something new for us to do, so you always want to keep pushing your limits. You always want to keep learning. It's always good.
It's always good. Okay, so saying that, what is the movie of the week? Sorry, movie of the week is
Jurassic Park.
There you go. So so that is the theme song for Jurassic Park. And why should they be watching Jurassic Park?
Because I think there's a new one coming out, but also because it's the classic. So why not? I mean, you know, what's wrong with keeping dinosaurs in a park and then letting people watch it? It's cool. They should do it.
There you go.
They should just do it now.
Highly dangerous idea, but yes, it's very cool. And the idea of going back and looking for mosquitoes fallen into the gum to get the DNA was an interesting idea.
And it's also something that had merit and value in real life.
So there you go. So that is the movie of the week, and thoughts for this first part of this season.
It was good to get the design, the sort of general look.
Yeah.
Right? Yeah. All done on CAD software or computer-aided design software. Yes, it was good to, and then sort of make up the cowling for the motors. See how it sort of looks like in proportion. Yeah, sort of general idea.
Big, won't it?
Be quite large. Yeah, sort of around the sort of 2 meter mark, something like that.
The interesting thing for me was the tri-blade props, which was pretty cool. And the interesting thing was the quick release. So make sure you put them on the right way.
That's right. Make sure left is on the left side and right is on the right side.
There you go. Otherwise, it will unscrew itself. There you go. But it's an interesting one and quite good for packing things down so it doesn't take up so much space.
Yeah, and
transport.
Quite helpful in this one too because of the nature of the fact that the nacelles move.
And there you go. There you go. So that is the word of the week, is nacelles. There you go. So, okay, so we'll see each other next week for something exciting, and stick around for more on this build coming up.
That's right. Yeah.
Should be fun.
Yeah.
Okay, so thanks very much for tuning in. I'm Harry.
And I'm Richard. Special note to Team Motor.
Very cool.
We'll continue on this one. It's good. Why not?
Yeah, it's exciting. Okay, and
3, 2, 1, go! H outdoor racing, H outdoor racing, H outdoor racing!
yeah. Yeah, see you then.